Okay, quick review of the C++ that we'd like you to know going into data structures. So we'll cover some of this in class, and this is a video to help catch you up if, in case you're missing some of these concepts. So there's a list on here of what we need to have that's usually taught in the intro class. So knowing what a variable is, how to declare one, and how to use it, compiling from the command line, and that you might not have done if you've been using an IDE, a GUI. And so I'll show you how to do that in this video. So we'll talk about standard equals C++ 11. So even if you're using a GUI IDE, which is the uh, interactive development environment, you sometimes would have to add this for C++ to specify we're using the 2011 concepts, that some of the stuff that was introduced in 2011 version of the language. So math expressions, so that would be like plus signs, minus signs, ampersands, less than signs, all the relational operators, that kind of thing. The math library, so the math library has a lot of very good functions that are useful: square root, absolute value, things like that. So Boolean relational expressions, user input. So this can come in three ways. So we usually talk about the reading from the user. So we prompt the user, hey, what is your name? You wait for input, you read in that input. That's one way. So that's an interactive version. We'll also do reading in from a file. And then the third way is from the command line arguments. And then if else statements, so being able to work on those, switch statements, all three loops, while, do while, and the for loop. And so usually I know a lot of people don't use the do while very often, even in the industry. It's still good to know this from the fundamental aspect, like why are there three different types of loops? They all have a different purpose. And so that's usually taught in the intro course, understanding the difference between them and why you would use one versus another, and when to use the appropriate one. File input output, strings. Now in C++, we also have object string, and then we have the C strings, which is an array of characters. And so that's treating a string as if it was an array, because it is an array in memory, and how you manipulate those arrays. So two-dimensional arrays as well. Parallel arrays, if you've seen this, is you have two separate arrays where the index, so like index 5 maybe is Elizabeth Bosie, in the first array, and it has something about my details, maybe for teaching, and then in the second array it maps to it. So it's a parallel array, so index 5 is also referring to me. So that can be useful in certain scenarios. Inserting and deleting into arrays, that's a complex aspect in the sense that you have to move the elements. So hopefully you got some experience of that in the intro class, where if you had an array of 10 elements and you want to, and it's full, and you want to delete maybe index 3, and everything's in contiguous order in memory as well as in the array and in the indices. And so if you need to delete at index 3, you have to shift all the elements afterwards into that spot. And same with insert. So if it wasn't full and you had 8 elements and there's a size of 10 for the array, and you wanted to insert at index 3, you would shift the other elements out to make space for that one. So you can't just do a quick line of code to insert into the array. So there's more work involved. And so understanding that helps a lot in this class, because we're going to talk about different data structures and why we would use one versus another, or why one might be slower than another. And we'll even do mathematical analysis on algorithms that we look at, such as inserting and deleting into arrays, talking about how efficient it is. So array sentinels, this is where something like the C string array, which is an array of characters, a sentinel would be, you would have some kind of symbol that would designate the end of the array. And so if you're working with a C string, we'd use the null character to designate we've hit the end of that string. And so we have more space in memory holding that array. So if it's the word hello, which is 5 characters, we might have grabbed a spot in memory with 10 characters worth, and then we put in the letters HELLO because it's a character array, and then we put the null character at the end to designate that's the end of that string. So that's array sentinels is used in C strings, and otherwise you end up with really bad bugs. This can also be used with regular arrays too. So if you're filling up an array, let's say you're doing a line, so you're using the array data structure for keeping track of who's in line at the bank. And so that number changes, and so you need to keep track of, well, where's the end of the line? And so we'll get into some examples kind of working with arrays as far as the data structure called queue and how we manage that, and also stack. We'll end up doing an array implementation of it. So understanding array and array sentinels, very helpful for this class. A vector, which is, depending on your language, you might have seen it as vector or array list or something. And that's really more of a dynamic array. And so you can do one line of code to add and insert into the array or delete from the middle of the array. But what we're going to look at this semester is see that data structure in more depth, where it's actually doing all the code that you would do yourself if you implemented the array yourself. So you're not really bypassing the efficiency. As a programmer, it's more efficient because it's a one-line piece of code, which makes it a lot faster for us to code it. But as far as the speed of the actual code being implemented, it's still doing the same thing we would do if we implemented it using an array. Functions, so being able to create your own functions, to call functions, and understanding how that works. We'll go into some details during class 2 about the pass-by value versus pass-by reference. Pointers, we haven't done the malloc or a version of that for C++. So we'll get into that this semester as well, just to make sure everyone understands. Pointers is a big one. So usually it's introduced in the intro class, and you may not totally understand it. It usually takes some time for most people to wrap their head around pointers, how they work, and how they're useful. And so hopefully you got an introduction to it just to get your brain started on processing what a pointer is and how it works. And we'll go into more detail this semester. So that's a big one I would definitely take a look at, read up on for this class. Pass by value, pass by reference, so that's with our functions or methods. Struct, so with C and C++, we have the struct where we can create our own data structure with a bunch of variables in it. And so that's kind of a precursor getting into OOP, or object-oriented programming, with classes, where the struct just has data values. So we just put some variables in there. For classes, we're going to have variables in there, and then we can also have methods inside there. And then header files, we'll go over this in class as well. That goes into more detail about how in C++ we manage our classes. So we usually separate the class definition into a header file, and then in our CPP file, we will reference that header file and have the actual code for those methods. And that becomes useful because when we write in code in other places, if we ever need to make use of a class, we can include the header file, which just defines what the class is, and not have all the code pasted in there. And so this has to do with the efficiency of how C++ does the combining of the code when it does the compilation. Okay, so that's kind of a quick review of the concepts that we want to look at. So let's take a look at an example where if we start off with just the very basics for C++. So if I'm going to set up a file, now I'm using Vim. You can use an IDE in this class. You could, which is if you're using Eclipse, if you're using any Atom, there's so many, Sublime, there's tons of different options for editors. You can also use Notepad, but that would be really painful. So in Unix, we can use, or Linux, we can use Vim or Emacs are the two popular ones. And when you move on to Methods and Tools, which is 3308, you should be learning at least one of them, or at least get introduced to both. And as in a computer science degree, you should know either Vim or Emacs eventually. Not for this class, but I'll be using it just because it's awesome. All right, so I'm going to just set up a quick file, so an intro CPP file. And one thing, just want to, this is real basic, make sure that we include our libraries. So the #include is how we include libraries. IOStream is for input output, some of the basics, so we almost always need that with cout. which is what we use in C++ to print to the screen. And so another common one we might use is include string. And we'll also take a look in this video with string, which is very, very useful C++ that we want to make use of. And then what we do for the C++, we need to keep track of essentially a namespace. So what we're doing is we're using a namespace. So we're going to be calling using namespace standard. Now, as far as the details of what a namespace is, we're not really going into that kind of detail, and you probably didn't get into that in the intro class. Worth reading up if you're going to be doing C++ in the future. As far as this class, we are just like the intro class. We are using C++ as a vehicle for learning data structures. So this is not focused on really learning hardcore C++. And so using namespace standards is more of a C++ thing. We're not going to get into the details of that. You're welcome to do that yourself. But we are just going to make use of it, and I'll tell you how to use it and when not to use it, that kind of thing. But worth looking into if you're interested. And then, so once we have that, we set up our main. Now, typically in C and C++, we have int main. You can actually do a void main, and we can also add parameters in here, which we'll see later as well. So technically, if you have a return type of int, you should return something. And a lot of times, especially novice programmers, we may forget to do this. And so usually what happens in these types of programs is if it executes successfully, we return 0, that there was no error. And we would usually return a value if there was some sort of error. So that's what we should have on there if we're going to have the return, the int in there. Now, your program will still compile if you have the int return type and you don't return anything. It just seems to assume it's going to be returning of 0. But you should follow the proper programming practices, and especially because that getting away with that in other programming languages doesn't necessarily work. So the very basics, we have cout, and then we have the less than sign, which is our directional to cout is for our screen output, and then we can say our famous hello world. We use the semicolon in C++. The other thing we might want to do is use the new line. So if I were to type another thing, my name is. All right, so let's just do that. What we'll see is I didn't specify a new line character of any type, and so this should all go in the same line. So let's look at compiling this. So I would do G. Now, we could do, there's a multiple different compilers, so you could have something other than G++ if you're doing it from the command line, or if you look in your GUI IDE and you look in the settings somewhere, you'll see it calling some kind of compiler. And so it doesn't generally matter. The biggest thing would be whether or not it's using the standard equals C++11. So this one, we're not really using anything too fancy, so we might be able to do intro.cpp. And then if there's nothing that comes out of that, if there were any errors, it would have specified it. But what we're going to be doing this semester is making use of standard equals C++11. So we're just going to get into the habit of always including standard. So dash is an option, std equals C++11. And then I can do this. And again, I'm doing it from the command line. For this semester, you don't have to, but I will be doing that in lectures as well as here, because if you're using a GUI, it's usually pretty easy to figure out. But if you ever have to do it from the command line, at least you have seen it for an entire semester with me doing it. And that can become important if mechanical engineers and if you're ever working in space or something and you don't have access to a GUI, like if you're logging into a little cockroach robot for search and rescue, there's not going to be enough space on there to have a big GUI IDE like Eclipse or IntelliJ or whatever. So sometimes you'll have to work from the command line. So it's always good to have that background skill. That's why I teach it this way. All right, so I could do that and I would get the same result because it's just the C++11 is just adding more features that we could be using in our code. No big deal. All right, and then what happens is I didn't specify the executable, the name of the executable, so it always defaults to a.out. Now, if I just type a.out from the command line, it doesn't recognize that command, and that's going into how the operating system works. Now, what we could do, what you would just do is do a period to specify the current directory, which is a Unix Linux thing, and then I can do a.out, and so then it'll recognize it. Now you'll see that the hello world and my name is on the same line. And so I'm going to go back in there. I'm going to do my little shortcut. And so there's two ways to do it. One is the new line character, and which would look like \n, which hopefully you've seen in the intro class as an escape sequence, so the \. And in C++, we usually use the endl. So endl is frequently used for us and helps flush the output, the buffer from the output, which won't be so much of an issue this semester, but eventually you'll need to know that. Now I can recompile it and then rerun it. And hello world, and then I had the escape sequence, so that went to the next line, and then I also did the endl, which also goes to the next line, so that's why there's a blank line here. And then I didn't do it after Elizabeth, but that's what I would probably prefer to do. So that was some of the basics of a program. Okay, so let's take a look just quickly. If so here I have my line numbers as well. I can do no new for short for no new numbers. So things you should know already is the if statement. So in the C++, it's actually very similar to most other programming languages. We have the if, we use the curly braces. Python's probably one of the ones that doesn't do stuff like that. And then we have, usually the curly braces are good to always put in there. And now you may say, well, there's only one line in the if and the else if, so you don't actually need it. While that's true, and this is a really small program, in industry what happens is over time, I might not need to come back in here and add more code to this if statement. And so if the curly braces are already there, it's less error prone. That a user who comes in to do a fix, to do a feature add, will add code inside the if and not have to add the curly braces themselves because they're already there. It makes it cleaner, easier to read the code. It's much easier to see where it matches to the else. And so in general, it's a good programming practice to put them in there, even if there's only one line of code in there. Of course, for industry, you would really want to check whatever company you work for, what their standards are. If you Google Google's standard programming, they have their information on the internet, last I checked. So the if and the else if and the else, you should know how this would work. So if you're not, you can type this in and change age to different values and make sure you understand how that works. The relational operators, the less than and the ands and the ors and things like that. Then for loops, so here is just a simple loop. There are 3 loops, so ideally you should know what all 3 are, especially if you're going to be a computer science major or minor. So you're familiar with why there are 3 loops and when you would use each one. Granted, most people don't use do while very often, but there can be use cases where that's very useful to know about it and how to use it. Primarily, I want students to at least know the difference between when to use while and when to use for. And so the while loop, you don't know how long it's going to go until it stops. And then the for loop, you should use if you know how many iterations you're going to do. So if you're counting from 1 to 100, or through the size of the array, whatever the size of the array is, that's a for loop because you know when you're going to quit. While is one of those things where you need to check each time through the loop, whether you're going to quit or not. Like if you're playing a game and maybe it's the high-low game until they guess the right number. Do you want to play again? Well, you don't know until the user types in yes or no. And so it's not predetermined in any way how long that's going to be. And so you may also quit early. You might use a while loop. So if you're going to quit early, so if there's some reason that maybe you're going to pick 10 people out of 10,000 And so once you picked 10, so if you're going to quit early, there would be a good reason to use a while loop as well. And so make sure you're familiar with this. And the biggest thing for loops is to watch the being off by one error. So how many times does it go through this loop? Make sure you know exactly how many times you're able to figure that information out. How many times it goes through the loop, how many times it executes inside here, when would it quit? And the other thing with our loops is it's nice to be able to do a more complex conditional. Like we can have and half is greater, less than, maybe less than 20 or something. And so you can do a more complex conditional in your while loop as well as your for loop. And so I'll frequently do that in the for loop, which I'll show during the semester, some examples. So really something like if you're walking through the loop through an array, so normally you would go n times. So if the size of the array is n, you would go n times. But I might have, I'm doing a search. So once I find the element, I want to quit early so it's more efficient loop. So I don't, if n is 20,000 people and I find it after looking at 100, I want my loop to stop. I don't want it to keep going even though I found what I was looking for. And so that might be another example where you would want to stop early. All right, so then with functions, so another thing we want is the function. So here I've got my include statement using namespace, and I have a function up top and then my main. And so this is actually not how we do it in C++, but this is the quick introduction. In C++, we use function prototypes instead of setting it up quite like this. So here, though, this is the basic introduction to functions. You have the return type, the name of the function, and the parameters. And so this is just going to return the parameters added together. And so inside main, I can call getSum. The result comes back, and I can print that out. And then what's up here is one of the ways to really designate the comments. And so when you get into industry, a lot of times we have more details for describing a particular function or method. And the @ sign, what this is for is there's auto documenters. So Doxygen is an example. Java Doc, if you're programming in Java, is another example. Sphinx, if you're doing Python, where if you follow this format, it will auto-generate either a PDF or HTML files or both of all your code with this information, so that people who need to use your code base, they don't have to look at the code. They can read the same thing you would find on the internet if you're looking up how to use the Java or C++ language. It's all formatted for you. So it's a really nice documentation type tool. So I wanted to show that. All right, so now with our functions, what we normally do with our functions then is so I'm going to get rid of the beautiful comments. All right, so here's our function. So I would usually take these lines and put them after main. So main's where the driving force is. That's the driver program, and so we like to usually see that near the beginning of the file. Now, the problem with this is if I try to run the program right now, or even compile it, so if I do G++01, it will give me an error because it doesn't know what getSum is. It's undeclared. So when I come back in here, what we do in C++ then is make a function prototype, which means before main, before it's ever called, so it doesn't have to be main, but before getSum is called, I need to declare what it looks like so that the compiler knows, okay, getSum is the name of the method or function. It returns an int, and it takes 2 int parameters. So now when it sees get sum here in main, it knows, okay, it's going to take two integers, so age better be an integer or convertible to an integer, and the 5, that's okay, and it's going to return an int, so we can store that into an int variable, that's fine. So convertible just meaning you can go from int to double or int to float because it's a widening conversion. Hopefully that got covered in intro class. You're not losing any data. But let's say you had a double like 3.14 and you try to store that into an int. That's a narrowing conversion, and that's illegal because the compiler doesn't know what to do with that 0.14. Do you just want it rounded? Do you want it truncated? Or how do you want to handle that? And so it gives an error message. Now, there's a way to force it to do that, and that's called casting. So hopefully you've done casting as well. So casting, so for example, if the age was 12.75, which is a double, I could say intentionally I want it to be converted to an int. So I cast by putting the int data type in front of the double variable there. All right, so now one of the tricky ones is the input where we have cin versus getLine. So for cin, what we do, this was one way to read an input from the user. So if you prompt a user for their name, so you'd want to have some kind of prompt because otherwise it looks like your program's just hanging. And then you can call cin, which is this line here, to read in your name. Now, the cin you have to be really careful about because it considers any white space like a tab or a space or a new line as a terminating value for the value being extracted. And so if you're trying to get the string, you always extract a single word, not an entire phrase or sentence. So for example, if I'm doing cin and trying to read in your name, and let's say I put Elizabeth Bosie, so it's my first and last name, this is only going to read in that first name. And then the cursor is going to be waiting for, right on the B for Bosie for my last name, for the next round of when you ask for input from the user. And so things can get a little confusing and weird. So most people now use getLine. So you can still use cin directly like this with the less than sign to read in the values. But most programmers will tend to use the getLine. And then cin is still the input. That's where the stream of values are coming in from, which is from the user. And then you can store it into a string called your name. So string is an object or class in C++. So it's not in C because C doesn't have any classes. And so here we getLine. getLine will get the entire line until it finds the new line character. And so that's the key there. So getLine's usually typically just easier to work with. And what you can do, you can always, we'll look at string stream soon, which you can read in a whole line, like Elizabeth Bosie and computer science or whatnot. And then once you've read in the whole line into the code, you can then parse that line and use delimiters. And there's other ways to grab each of those values. But typically it's easier to read in the full line. Same with reading in from a file, same kind of concept. It's usually easier to read in the full line at a time and then process that line and do what you need to do. Now, the biggest worry though, you can still use cin if you prefer, you can use getLine, getLine being preferred. I just highly recommend do not mix and match. It gets really confusing in the code what's going on if you're using cin that's using any kind of white space as its delimiter of where to read in from, versus getLine, which is reading to the new line character. And so use one or the other, but don't mix and match them. That's kind of the key there. Okay, so string stream. So here with string, this allows us to take in a string and make it into a stream. So takes the string that we have and puts it into a stream so that we can use any of the functions or methods on streams, which is nice. So in this example, we're prompting the user for enter price, and we have getLine. So this is going to read in from the user, so cin, and it's going to read all the way to the new line character. So temp string is our string, which is an object, is going to store the value of what other user types. And then for string stream, what we're going to do is we're sending in the string. So we made the string, this is my string variable, temp string, and we're going to make it into a stream, which means we can then use the greater than sign to store it into some variable. And so we can do a lot more complex stuff with string stream as well. For example, opening files is typically a good one for that. So let's see. So here, what we have for the file input, we have another library that we have to include, so fstream up the top. So we have iostream, which we usually have in the fstream for file stream. So again, we're working with streams. So we have input file, so if is input file stream, and of is the output file stream, so in file, out file. All right, so I'm going to open my data file. So I am hard coding my file name here, which in most programs we would never do. We'd read it probably from command line arguments, but just for the simple example, we'll keep it easy. And for reading the input from a user, we have to check if it's open. And in C++, and if you Google this and find, or even read books on it, there's a bunch of different options. You could call the method open versus is_open. So you want to be careful about the difference between them. So we're going to want to use the is_open. This is going to check and verify that this file exists and is open and ready. And then if that's the case, we're going to open an output file. So this is the file we're going to send output to. And so we're also, for any output file, we also have to check to make sure it's valid and ready to go. So here we're going to create a variable called line to store the values when we read in from the file. Now this is how it's typically done, is all in one line. And so if you hopefully are used to this from the intro class, we do the get line as the conditional inside the while loop. And so this get line is going to read in from the in file, so the one that we're trying to read the data from, store it into my string variable called line. And then the get line is clearly returning some kind of value to the while, because while needs a conditional here. It needs to be essentially true or false. And so getLine is going to return to us whether it was successful or not. And so if it was successful, it's going to go inside the loop. And so this is how it's typically done, all in one line. So if that's confusing, I highly recommend kind of playing around with this and trying different things to get familiar with it, because it's a nice, easy way to read in input from a file. So then here our output file. Now out file, that's our stream to go to the output file. So we want to write to output.txt. And so we're going to send in the variable line and then the new line character to that out file. Key thing to remember with files, always make sure you close them when you're done. And then this else statement is handling the case where there was something wrong with the output file when it wasn't able to open. So we're going to still make sure we close the in file because that one did successfully open. And so while in intro class and data structures, this class, you may not really notice a problem by not closing your files because when everything terminates, it's going to be fine. But when you're in industry and you write code or working on a code base that's expected to run 365 days a year without terminating, that's when you're going to run into problems. So you really want to make sure you're paying attention to that in these intro classes so it becomes a habit that you're always doing. All right, so let's go into the C string. Do I have C string? All right, so for C string, so here, this is the C string up here. So my word, and my word 2 is also a C string. And so 2 ways to initialize it. Hopefully this is a review. So this is the way C works with strings. So it's a character array. So we see the array with the square brackets and it's of type char. So each spot in the array is a single character. And then we end it with the null character to designate the end of the string. And so we need enough space, H-E-L-L-O, that's 5 characters, but with a C string, you always need an extra space in the array for the null character. And so if you were to do it like the second one, it will automatically add the null character at the end and make enough space for your array that way. So it's really, really important. A fun thing to do, I do this in the intro class, is don't terminate your strings, and eventually you'll see massive problems. What will happen, and you can Google this as well, is it will just keep writing what it finds in memory until it hits a null. Now, null is typically a 0. So not always, you always have to be careful. That's why we usually refer to the constant or the macro for the null. And so a lot of times in memory, you have a lot of zeros. So a lot of times it'll hit a 0 anyway. And so maybe it won't look like a problem. But then you'll run it one day and you'll get it printing out all these extra characters after the string, like after hello, and then all these weird characters. You might see hearts or diamonds or upside down question marks and stuff. So that means that's usually because you didn't null terminate your string. This is a really big deal, and this is where a lot of errors can be that are really hard to replicate. I love doing this during lecture in an intro class because out of 200 students, I'll always get like 5 who will have weird output, whereas the rest of the students it'll just happen to have a 0 in memory in that space right after the characters, and so it won't look like a problem. And so it kind of helps show everyone what this problem is. But this is worth Googling as well to get, if you're really into understanding more in depth in the fundamentals, because this is a real big issue. And there's even XKCD comics on it. And in the security world, this is a big deal because if you don't null terminate your string, you might be able to run into a password file and get people's passwords and all these crazy things. So C strings, that's a character array. It's typically used in C. In C++, we have a string, so we don't necessarily need the C string as much. We typically use the class, and so C does not have classes. C++ is object-oriented and has classes. So that's a big difference there. All right, so command line arguments. Command line arguments. So here what we have for command line arguments is when we have our main function, we include parameters, and you have to include both of these in C++. So argc is the arg count, or command line arguments, the count, so how many. And argv is an array of all those values. And you can see it's coming in as a char star. So it's essentially coming from the C programming code base, where they didn't have strings, so these came in as an array of char stars. So now what I'm talking about for this, so if I were to compile this, so I'm going to use standard equals C++11. So when I run a.out, it's all the values I put here after the executable. So now the beauty of this is we see I did something wrong when I tried to run the program. And so the usage statement is what's commonly done in programs, and you'll see this a lot in the Unix Linux environment. Uh, they'll typically do that as well. So if we go back in here, it says if the arg count is not equal to 2, then tell the user they did it wrong. They're not using your program correctly. So the usage, how do you use this program? And then argv index 0. So the key thing here is at index 0, the first spot in this array is the name of the program. And then you're supposed to put a number. So we can only run it with a number afterwards. All right, that's the way that one's set up. Okay, so now when I saw the usage statement, notice that it did /a.out. That was at index 0. It's the command line arguments takes this entire line and puts it into the char star array. So /a.out was the first in that. Essentially an array of C strings, or an array of character arrays. So the space is what it used as any kind of white space is the identifier to separate these tokens. And so index 0 would be the a.out, index 1 is 12, index 2 is Elizabeth, 3 is trees, 4 is bikes. All right, so now since we're talking about a.out, what if I were to name it something different? So if I were to compile my program and I go, there's my compiler. If I do the -o option, that's my output executable. And so I can name it CLA execute command line arguments. So now what happens is I have this CLA exec executable instead of a.out. So now when I do, instead of doing a.out, I can do the exec. And so now I didn't do it correctly. My usage statement shows up, and you can see it has that at index 0. And if I do it again with a number, it works. So command line arguments is critical. That's the way we primarily make a program that we can be useful for many things. So we can create a program that can be used many times with, in this example, different numbers to do some kind of calculation. And the other thing that we typically do with command line arguments is we will send in the name of the file that needs to be processed. So command line arguments and file input are both two really critical components. You'll need them all semester because it's just really basics for programs. All right, arrays. Okay, so for our arrays, here we have a constant int num months. So going to best practices, instead of just putting the 12 in there, those are called magic numbers. If you put random numbers everywhere in your code, makes it hard to replace if something changes. Maybe the number of months won't change, but apparently the number of planets did change in the last decade. So, you just don't know when something, like if it's sales tax or interest rate, all those values could be changing. So you want to use constants. So constant should have been covered in intro. You just declare it as constant. This is just a reminder to make sure you're using it. When you declare your arrays, you should specify the size using a constant, referencing the constant instead of just hard coding it in. So this is two different arrays. We have an array of strings. So here, these are string values, and it's an initializer list with the curly braces. And this one is number of days in month, which is a bunch of integers. And how do you create that? And then you reference them from the indices. And then the most common thing you do is you do your for loop. And again, reference the constant, not the hard-coded value. Now for vectors, okay, so for vectors, here we have an extra library called vector that we can use for C++. Vector, what we do is, here's my variable name is scores, and I'm going to designate that I'm going to put int values in this vector. And the key is the pushback. So that's how you can just add to the end of the list. And that's kind of odd compared to some other languages. What language is using push underscore back, but that is what it is. And some of the good methods that we can make use of, something like size. This will tell us the size of the vector, and the pop back is how you can grab something off the vector and then check out the size. You can also, it's vector is based on an array, so it's just somebody wrote code to manipulate the array for you to make life a little bit easier for you. And in the guts of it, like if you Google the vector class in C++ on the internet, you'll see exactly the code that it's using is just manipulating an array. And so the difference between size and capacity. So capacity is how big, how much space is allocated for this array. So one of the key things to remember about arrays, which we need to know for this semester, is that the array has to be contiguous in memory. So if you're starting at spot 1000 and you grab 100 spots and they're all together in memory, and that's important because we're going to look at a linked list which doesn't have that requirement and makes it a little more versatile for grabbing random spots in memory. So now with an array, if you run out of space, you cannot just keep adding to the end of the array because maybe there's other data already being stored there, or maybe your favorite video game starts there in memory. You can't just override it. So one of the things we're going to do this semester is an array doubling. So how would you write the code to then, if you run out of space in your array and you need a bigger array, you have to go grab a bigger spot in memory that's contiguous, because that's a requirement of the array, and then copy those values over and then free up the old memory. And so vector is doing that for you, and capacity is how much space is available to it, like how much memory is saved for it, and size is the number of elements in there. And so that's another key thing to kind of understand how it's working in the fundamental aspects of how the array actually works and how a vector is making use of that array. And we'll be talking about that in more detail this semester, and then comparing them. For the struct, what we're doing is essentially creating a data type. So we create a data type called weather data, and we've got 3 variables that we're specifying. So it's really just a way to group variables for a given data variable. So here, if I have weather data down in my main, so weather data is a variable data type, just like all our other variable data types. And then I have my variable name, so dp1. And dp1 could have been bolder. And we could have set the humidity, the temperature, and the wind velocity for this particular weather data object 1. And then we can create another weather data for Denver, and then store its humidity, temperature, and wind velocity for that one as well. And so the way we reference it, so this is going to become important when we differentiate and start using pointers. For the weather data for the struct, we're using the period, the dot, to reference each of these variables. All right, so that's the basics of the struct. We're going to be using the struct quite heavily this semester because we'll use it for linked lists, and it's also kind of the base for classes. So as far as classes go, we'll put that into a separate video, and this is it for hopefully what you've covered in the intro class, and if not, hopefully this will give you some background and things to look at and play with to get ready for this class, data structures.